When creating a design in Fusion 360's single modeling environment, it's important to have a good understanding of the differences between bodies and components. Bodies are modeling entities used to add or remove geometry to achieve the final shape of your design. Components represent real-world parts of an assembly that can be defined to have a certain range of motion. Let's take a look at the differences between them, along with their downstream effects, using this support bracket model. Bodies and components are distinguished from one another here in the browser. Currently, this model contains a single body, shown in the Bodies folder, as well as a single component shown below. Each has a different icon. The body has a cylinder icon, and the component has a cube icon. There's one other icon I'd like to point out, the icon for the top-level design. Notice that if I delete the component from the design, the icon at the top level changes to a cube, indicating that the entire design is now a component, which can contain bodies and sketches. However, if I bring the component back in by clicking Undo, the icon changes to an assembly icon, indicating that the entire design now contains components as well as bodies, and can even contain subassemblies, which will be covered later on in this course. Before I create any more geometry, I'd like to point out how bodies and components perform in the design. Because bodies are modeling entities used to create geometry, they don't have any open degrees of freedom and are fixed in space. If I try to drag the piping fixture, it won't move because it's currently a body in the design. However, since components are used to enable motion and represent real-life parts, such as this bracket, it can be dragged and moved around in the model. I'll click the Revert option to reposition it. Diving deeper into understanding components, I'll expand the bracket component in the browser. Notice that the component contains a body. This is a fundamental aspect of components. They are containers for other modeling entities, which can include sketches, construction geometry, bodies, and even other components. Whatever associated geometry is contained in that component will be moved around and transferred with the component. There are a few ways to create components in a design. One way is to create a component as a blank component that can be used to keep future geometry self-contained. To create this blank component, simply right-click on the top-level design in the browser, then select New Component. This component only contains reference geometry in the Origin folder. I'll undo adding this new component for now. New components can also be created while creating a new 3D feature. For instance, if I create a sleeve on the end of a pipe connector using a Revolve feature, the operation type can be set to New Component, which would immediately create a new component in the browser containing the new body. However, for now, I'll simply choose the option New Body and continue on. One of the simplest ways of creating a component is by using an existing body. For instance, if I want to create a component using the pipe connector, I can right-click on it in the browser and then select Create Components from Bodies. The body is now reorganized within the newly created component in the browser. Additionally, because this body was used to create a new component, it's now free to be repositioned in the design as opposed to being fixed in place. Now that you've seen some of the differences between bodies and components, I'll walk through some of the downstream effects that occur when adding geometry to the model using a body versus a component. To do this, I'll hide the bracket component in the design window and show the ring sketch. First, I'll demonstrate how modifying a body affects downstream features. To do this, I'll quickly circular pattern the sleeve. I'll enable the Circular Pattern command, then switch the type to Pattern Bodies. Since I'm patterning a body in the design, select the sleeve, choose the axis to pattern around, increase the quantity to 4, and make sure to skip the instance at the back. Now, if I use the press-pull command to pull out the front face of the initial sleeve, only that body is affected. This is because Fusion 360 treats individual bodies separately within the top-level design. However, because Fusion 360 is parametric, moving this modification in the timeline before the circular pattern command will cause all of the other instances to update as well. This is a quick and simple way to modify multiple bodies downstream. I'll quickly undo these changes to move on. Now I'll show the same scenario of modifying the initial sleeve. However, this time it will be set as a component. To change the body to a component, I'll right-click on it and select Create Components from Bodies. Now, if I circular pattern the component, once again skipping the instance at the back, and use the press-pull command once again to pull out the front face on the sleeve, all of the components are modified simultaneously rather than a single instance. This is because Fusion 360 treats the patterned components as copies of the original. This is represented in the browser by multiple components sharing the same name, followed by an instance number. It's important to keep bodies and components defined properly in the model, as they are manipulated differently and have differing downstream effects in the design.